Now, before we start on this exercise, which is called the rotated boxes exercise, I am going to give you a little bit of a caveat. This exercise is really hard. This one and the one after it, the organic perspective boxes exercise, were included here not with the intention of having you kind of do it perfectly and then move on. It's really difficult. The point of it is to get students to start thinking about 3D space in a different way. It challenges you to work without plotting your perspective back, without thinking about where your vanishing points are explicitly. And it forces you to work more organically and look at neighboring forms and try and infer what the kind of perspective of this space is. On top of that, it kind of teaches you that it's okay to fail. Failure is a very important part of the learning process. If you are just expecting to have success in every area, and if you cannot handle defeat and failure, you are not going to make it very far, because failure is really what teaches us the most. So if and when you mess up on this exercise, don't worry about it. All you should be striving to do is follow the instructions as closely as possible. Don't skip steps. Don't glaze over the text written in the lesson page. Just focus on following it step by step. And if you have trouble, if you mess up, that's fine. So this exercise involves creating a sort of network of, it's sort of boxes. They're not exactly boxes, because technically we wouldn't be able to do this with proper boxes, but I'll show you what I mean in a second. So we start off this exercise by creating a cross, just our axes in the center. And we start off with a simple box. Now this box is not like the boxes that we usually deal with, which are like cuboid. They have right angles all over. This box is going to be a little bit tapered. Now you can't actually tell that it's tapered, not from this, but based on how all our other boxes will be arranged, it will essentially be impossible for it not to be tapered. By tapered, I mean if you were looking at it from the top, it kind of converges like this instead of being straight. So we have a box, standard 1-point perspective, just plotted in there. And remember, this is freehand. You can use a ruler for the axes. But not for your boxes. And basically what we want to do is we want to create a rotation. We want to draw in a bunch of, I'll just put this in real quickly. We want to close them in so that we get this whole range of rotation in all directions. Kind of like this. So that's basically the idea. We can end up filling in our corners as well, and a lot of people get kind of scared and overwhelmed by this. So that's what we're going to be aiming for. But to achieve this, we want to start out by thinking about what our range of rotation is going to be. So right now we have the center, but we don't know what the extremities are going to be. And the reason that I want to kind of define this right now is that people have a tendency of trying to do a full 180-degree rotation of boxes, and they'll only end up doing like 40 or 50 degrees worth. But if we actually draw in what we're kind of rotating towards, which are just more boxes that are rotated like 90 degrees from this one, so we're just looking at their side faces. This gives us a sort of visual cue as to how far we need to rotate. Just helps us think about what we're doing a little bit more. Now you'll notice that I'm not actually drawing through these boxes because they're only supposed to exist as kind of guides. So we just want to have them sitting there as though we're looking at this, the side face of these boxes. Now the real work comes in when we start drawing in our next box. So I am estimating. Based on what I know about 3D space, I am not going to be placing or plotting back towards a specific vanishing point. I do know, though, that I am not drawing towards this vanishing point. As a box rotates, which I actually show in the lesson, there's a little animated diagram, the vanishing point slides along the horizon. So if this vanishing point were here, it would move ever so slightly in this direction as the box rotated to be in this state. So if I was actually plotting it back, it would be, I don't know, somewhere like this maybe. Something like that. But the point of this exercise is not to actually plot them back like that. The point is to estimate it organically, knowing what we know about boxes in 3D space. And we do want to make sure that we draw through all of our boxes and the beauty of this exercise is that we've got so many boxes lined up so closely together that we can actually use these edges, neighboring edges, as hints for what the neighboring line is going to be, what it's going to look like. Because these lines are so close together that their convergence towards whatever vanishing point, in this case they're just going straight up and down, but even if they weren't, which you'll see later, their convergence doesn't need to be any visibly different. So we can use that as a sort of hint as we're building these. So you see this, this pairing here. These two lines can be essentially parallel to one another as we're drawing them. And it limits the amount of guesswork that we have to do. But the only way that you can actually take advantage of that is by keeping the gaps between your boxes narrow. Because if they're too far apart, then the trick doesn't work. So this box, as I was mentioning before with the tapering, this box cannot actually be perfectly like cuboid. It needs to be tapering somewhat, but we don't really need to think about that very much. Next, we put in our following box, which we want to kind of push its rotation further. So this line that I'm drawing here is a bit of a guess. So we do have to rely on some kind of educated guesswork, which is what makes this exercise so difficult. Because at this stage, at lesson 1, I don't expect students to have developed a kind of comprehensive understanding of 3D space. That comes with time, that comes with practice, that comes with doing exercises like this. So you're not necessarily going to be able to hammer it out so easily right off the bat. Also, notice how the extremities are way out to the side, that's perfectly fine. Like I said before, they're just guides. They're there to remind you that we want to cover this full range of rotation. Now, I'm only going to be doing one quadrant of this exercise because otherwise it'll be too time consuming to do on video, but it should give you the gist of the whole thing. So here I'm going to now this one has to be a guess again. So as the box rotates further away, the convergence of its lines gets more dramatic, so they converge much faster, and also the visible width of this plane, or this plane, will compress. Drawing through your boxes in this exercise is extremely important and helpful because it kind of teaches you how the box itself sits in 3D space, because you get a full understanding of where all the lines and all the faces are. Whereas if you were just drawing like the faces that you could see and the edges that you could see, you'd only understand it insofar as it exists and sits on the page. So we want to know how it sits in 3D space, and then we want to kind of get our heads around how that changes as the box itself rotates. So now I want to draw this corner here. Now I'm going to use the fact that I can use these lines here as hints by keeping my gaps nice and narrow. And same here. And then same here. It does get very visually confusing at times because there's just so many lines floating around. That's the downside to drawing through your boxes, but it's well worth it. Now we've got a couple of lines that are definite guesses. We do know that as these boxes kind of rotate away, the convergence of those lines compresses and it gets more dramatic. So where this one would be less dramatic, this one is going to be more dramatic. And same with this one here. And that's kind of an educated guess at this point, based on what I know about 3D space. Same here. And that's basically the gist of doing one quadrant. So, I mean, since it's very visually confusing, adding line weight and stuff like that can help considerably. Usually I kind of add a bit of cross-hatching to clarify which face is which. It's not necessary, but it does kind of help, and I don't know. People usually tend to feel more proud of their work once they've done this, but don't focus on doing it. Instead, you want to put all your effort towards following the instructions, making sure your gaps are narrow and consistent, and kind of leveraging what you do know thus far about 3D space. And so yeah, that's one quadrant. All the other quadrants follow the exact same steps. So I also have a pretty detailed breakdown of how to approach this exercise on the website itself, in the lesson, in the exercise description. So follow that as you're working through it. Just make sure you're drawing through your boxes. Which again means drawing every single line that makes up the box, including the ones on the far side that you can't see. And yeah, keep your gaps narrow. And so on. And just try not to get overwhelmed. If you find yourself getting confused and like just that it's too much, take a break. Don't push through when and guess when there's no need to. And of course, last of all, remember that it's meant to be difficult. So try it once, and chances are that the best next step after this is to tackle the 250 box challenge. Which is, again, on the website. Again, when you're doing that, draw through your boxes again. Also, there's some correction methodology there that's pretty useful to use, where you extend your line back towards the implied vanishing point. After you've drawn a box, or after you've drawn a bunch of boxes, you've got these, so let's say you've drawn a box here. So let's say you've drawn this box for the challenge, then you can actually extend the lines back similarly to the rough perspective approach, but it's a little bit more comprehensive, where you know all of these red lines need to be parallel, meaning that they should be converging towards the same vanishing point, but obviously they don't. They converge here, 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 and here, which means that it's technically incorrect. So they should actually be all more coming towards an average point. But that shows you where you're going wrong and where things are incorrect. And you do it for all three sets of parallel lines. But again, I go through this explanation on the box challenge page, so be sure to apply it. This one is actually somewhat better. They're closer together. That's the main thing about estimating perspective in this way, that you're not... no one's expecting you to do it perfectly. They're expecting you to be within a certain margin of error. And after a certain point, errors become obvious to the naked eye. And if they're obvious to your viewer, then that's obviously a problem. But it's still going to be a problem within a certain kind of margin, even if people can't tell. Yeah, so that should be it for this exercise. And I hope you guys don't go too crazy over it.